Perfect. Hi, everyone. In today's session, we would be learning many interesting details about how the internet actually works under the hood. We would be understanding nitties and gritties of internet in detail. All of us have been using internet every day, either by accessing websites on our laptops or on mobile phones. But we hardly ever think about how it works under the hood, how everything comes up on our screen so easily. And why are we discussing this? Why are we discussing internet so much in our prep course? The main reason behind is because later, while learning the core programming languages like your HTML, your CSS, JavaScript, your backend technologies, we will start putting our own websites on the internet. We would be making our own creations and put them on internet. At that point of time, it's very important to have at least a very high level understanding of how the internet actually works. So far, we have gone through basics of networking and internet. Today, I would be diving deep into two major questions. So what are those two major questions? The first question that comes to my mind is what exactly internet is. We will see all the details associated with it. And the second question that comes to my mind is how does it actually work? So these are the two questions that we would be targeting. So we must have thought that okay, we really understood what internet is in last sessions, but we only touched the surface. Now we would be covering some basic parts and structures of internet, how it has been spread across the globe. Now we would be talking at global level as well. And then how does it actually work? How data is actually getting transferred from one system to the other. So these are the two major questions that we would be dealing. So let's see our first question. What is internet? So let's move on to our first question. So as we have discussed, internet is first and foremost a way of making information and knowledge open and accessible to all. So that is the founding principle. Remember, this is the founding principle of our definition of internet, that making information accessible to all, making internet as a path where information is available to everyone. Second comes physically, the internet is a network of networks. It is a network connecting other computer networks. We would be diving into great detail today. We would be studying networks in great detail today, what actually networks are, how they are composed, types of different networks, and so much more. Third, I would say it is built on open, agreed protocols. So very important, open and agreed protocols. What are agreed protocols? These are set of defined rules, standardized rules that computers and devices follow while accessing the internet. So these are set of rules, remember. These rules we do not need to make. They have already been made. There is a special agency that is called IETF, that is Internet Engineering Task Force. That agency is responsible for standardizing all the protocols. They have been doing this for us. We just need to follow them, and it's very important to follow them. So we would be understanding why it is important to follow them. So now, if we define internet uh, in a small definition, I would say it is a way for all machines to communicate with each other. So what is simply an internet? It is a way through which machines can communicate with each other. And now, if machines can communicate, it enables humans to communicate with each other. So because machines can communicate, with the help of machines, we as humans can communicate with each other. And that's very important point. That really changed our world by creating a way for humans to communicate so easily with each other, no matter where we are. I'm sitting here hundreds and thousands of kilometers far away from you, but we are communicating so seamlessly, without any lag, without any latency, so smoothly. And that is possible through many, many functions and many abilities that internet provide us. So it's a very simple definition. Internet is a way for access that makes information available to everyone. It is a network of networks, and it follows set of rules, agreed protocols. It makes machines communicate with each other. It helps humans communicate with each other. So now the question that comes to our mind is, how does it actually work? We understood what is internet. We dealt with our first question. The major part of the today's section is, how does it actually work? So let's get started with that. So uh, if we're talking about how does it work, we need we can get some other questions also, like how does internet enable all machines to communicate with each other globally? So how internet enables each and every machine to get in touch with each other globally on a mass level? So well, it starts with protocols. Let's introduce protocols. So what are protocols? In a short definition, we understood these are set of rules. So now let's dive deep into protocols. A protocol is a widely agreed set of rules. As the basic definition that we discussed, set of rules and agreed upon. All the agencies, all the institutes, all the companies that are on the internet have agreed to follow those rules. Now, protocol standardizes the communication between set of machines. So protocol standardizes the communication. If one machine is A and other machine is B, they can only get in touch with each other. They can only talk if they are following the same protocol. If they are not following the same protocols, they cannot talk to each other. So next question comes, how this is happening on our computers. So let's dive into some computer science topics, very important to understand for every one of us. So you may be familiar with this, but the core computers, the computers that we are using, represent all information using only binary numbers. So computers only understand binary number language. They do not understand the English that we speak, or French, or any native language of specific regions. The computers do not understand that. They only understand binary numbers. And this is called machine language. So by binary numbers, we mean only zeros and ones. So computer language only consists of number 0 and number 1. Everything gets converted into zeros and 1. All the information, whether it's colors, whether it's images, texts, or full websites, all information on computer is built up using only zeros and ones. So all human readable information. By human readable, I mean the language we speak. Everything converts into zeros and ones. In this, a very simple image, when we calculate like 25 times 25, that is the language we speak, but the computer cannot understand that. Computer needs to convert this number into a series of ones and zeros. Similarly, this number into series of ones and zeros, and then it computes the result and provides this one. This result is then converted back into human readable language so that we can understand. So major point that we need to make sure that we understand over here is that computers only understand binary language. So now these zeros and ones can be represented in a lot of different ways. We can represent these zeros and ones in many different ways. Let me give you a few examples, like these zeros and ones can represent positive and negative charge in a circuit. Whenever the electricity flows and we encounter a positive charge, we can mark it as 0. When it is a negative charge, we can mark it as 1, or vice versa. It could be used on lights. Whenever we see a light being on, we can mark it as 1. Whenever we see light is off, we can mark it as 0. So what you set 1 and 0 to is not important right now. What's most important is to remember the information that every computer stores using just values zeros and one. So every computer stores information using ones and zeros. So moving ahead, how protocol is connected to this information. So protocol is adopted to ensure that all computers interpreting zeros and ones in same ways. So what do I mean by that? So protocol ensures that all the computers on globe, all the computers worldwide Whenever they receive some information which is encoded in zeros and ones, they all interpret that information in same way. So let's understand with few examples. So suppose protocol might be like, hey, all computers, there are multiple bunch of computers there, and he orders the computers that we are going to agree to interpret the series 01000001 as letter A. Similarly, this bunch of series 01000010 as letter B. So this is how the computer converts letter A into language that computer can understand. Similarly, letter B is converted into bunch of zeros and ones. This is understood by each computer. So protocol ensures that every computer out there follows same set of rules, so that when this information is converted into binary, and when it reaches to this computer or this computer or this computer, it is always interpreted as same information for us. It should always be interpreted as letter A. Now, using this system, why computer science engineers used this system? There's a major reason behind that. Using this system like this, we can actually encode all the information that we possibly want to transfer. Whatever information we want to transfer across devices can be encoded into this. Let me show you a few examples. For instance, set of colors. There are certain set of colors like orange, pink, green that can be converted to zeros and ones. So just like this is the binary representation of color orange. This is the binary representation of color pink. Whenever computer receives this information, it knows that I have to display color orange. I have to display color pink when this binary number receives. Similarly, this is for green. So everything that we see on our screen behind under the hood, it is just ones and zeros. Colors, images, texts, videos, all is converted first to ones and zeros, and then that is again converted by our computers into human readable form. Why? Because computers only understand binary language, zeros and ones. So this zeros and ones is not restricted to your text or color. So another combination of ones and zeros may represent some action, like initiating a request or receiving a response. So for instance, when computer encounters certain binary number combination, it knows that I have initiated a request. When it encounters some other combination, it knows that I have received a response. So it might represent some address on the internet. So supposedly there is some address on the internet for particular video. Computer first converts that address into binary numbers so that it can understand what that address actually means. Because now computer knows what A is, what B is. Similarly, all the letters of English language can be converted to binary numbers. So we again come to the definition that protocol is just adopted to ensure all computers are interpreting ones and zeros in same way. So just look at this definition. Protocol, why it was adopted? Because it ensures that all these computers understand the combination of ones and zeros as same way. They're following same set of rules. So let me give you one example. Suppose there is a person from China. I'll mark it as C, and there is another person from Russia. So this person speaks Chinese, this person speaks Russian. Now they can't understand each other. Now both of them decided to learn English. Now this person learned English and this person also learned English. Now they can communicate. So whatever this person says, the same thing this person will comprehend and interpret. It would not, if this person says A, this person would understand what A is. But earlier, if a person was saying A in Chinese, some other language, let's say, the Russian guy was not able to interpret. So what's happening over here is they're coming to one set of rules. They're coming to one platform where they decided, okay, we will follow the rules of English for us so that we can understand each other. So this is a general example how computers decided to follow certain set of rules which are called protocols, so that whenever they receive some combination of ones and zeros, They understand in same way. This doesn't happen like if this goes over here, this computer will say it, okay, this is A. If this goes over here, this would say, okay, this is R. This doesn't happen because they are following same set of rules. This number means same for every device globally. So that's why protocol was adopted. So let's move ahead and see what internet lays out for us. So internet lays out series of protocols. There's not one protocol, there is series of protocols that all devices connected to internet must adopt. So just remember, not one protocol, there are series of protocol for different functions. In our previous lectures, we discussed very briefly some of them, like for emails, there is SMTP, Simple Mail Transfer Protocol. For file transfer, there is FTP, that is File Transfer Protocol, and so much more. The web browsers use HTTP, that is Hypertext Transfer Protocol. So there are series of protocol that all devices connected must adopt. So that way, why this is important? That way, all devices can communicate, no matter what type of device it is. If it is a computer or a phone or a desktop, whether it's your Apple, Windows, Linux, any operating system, they can communicate with each other because they are following same set of rules which were standardized. They are agreeing to send and receive information in same way. So Windows decided, okay, I would follow a particular path to send some information. So Apple decided, okay, same path I would follow. Android decided, okay, same path I would follow, and same with Linux. And to receive the information, if Windows decided something, Apple agreed to that, Android agreed to that, and so on. So all of these operating systems agreed collectively to follow same pathway for receiving and sending information. That's why they are able to communicate with each other. So now, because we are understanding binary numbers for the first time, we might be wondering how exactly this information is represented using ones and zeros. So that's not we need to worry about. Complex computer systems are converting the data into ones and zeros. Just remember, we can encode any information using binary, using ones and zeros. So like Ahmed is asking, for what reason the binary numbers are used. So the reason is that computers only understand zeros and ones. It was the machine language. Computer cannot understand English language because English language is very versatile. And to make things very under the set boundaries, the engineers decided to convert them. So for instance, you have heard about Morse code. Morse code is just like dit dash. So just like dots and dashes. A complete language to communicate is there using dots and dashes, and this is used by militaries. So why such small uh, set of things being used? So that there is very less confusion, and so that very less number of d- uh, different characters should be used. So that's why uh, zeros and ones were selected, because they were very easy to use and very easy to understand by each machine. Even for a very basic machine, zeros and ones were very easy to understand. So we can mark anything as zero, we can mark anything as one. So for instance, I would show you a few examples ahead. So just remember, we can encode any information using ones and zeros. Now, how does that work when it comes to internet? Let's move to internet, how zeros and ones is working for us. How is internet able to send ones and zeros between any two places on the globe? Let's see some examples. So how it is working? So let's see. Well, internet is just a wire. Just consider internet as a wire right now. It's not some cloud. It's not some magical thing happening up in the sky. It's literally a wire in the ground, spanning across the globe, running across the oceans, as we have seen in previous lectures. The wires are called submarine cables. Now, how does that wire sense zeros and ones? So a wire is composed of many parts. Some parts of wire can actually be made of copper wire, which you call your LAN wire. It could be called twisted pair cables. And we can use high voltages coming through the copper wire and mark it as one. We can use low voltages coming from the copper wire, we can mark it as 0. So whenever computer encounters some high voltage connection or high voltage data transfer, it marks it as 1. So it could be combination of 1 pulses. It's like a pulses. Similarly, when low voltage is encountered, it's combination of zeros. So it's like pulses being happening 1 1 1 0 1 0 1 1 1 and so much more. So accordingly, computer would understand how my connection is happening. What is my data speed? Am I experiencing high voltage? Am I experiencing low voltage? So that's how some parts of wire which are sending information electrically, they record through them. The systems record what is the combination, what type of network connectivity I'm having. So this was one part of wire. Some other parts of wire are like your fiber optic cables, in which we are just using lights to represent ones and zeros. So when light is on, computer records 1. When light is off, computer records 0. So similarly, we are using ones and zeros to catch the signal connectivity, to judge the signal connectivity. Even other parts of wire can transmit through radio waves. So a short type of radio wave may equal to 1. A long type of radio wave may equal to 0. So short type, that I'm able to receive signal very fast, that my wave has to travel very less distance, I can mark it as 1. I'm able to receive distance of, I'm able to receive signal after a long distance. I have to travel long distance. Then I'm providing the connectivity that can be a long wave. So it is represented as 0. So even other parts like radio waves, we can judge how a short wave is coming, how a long wave is coming. Why? Because we have provided ones and zeros to each of the data that we want to capture, because every data is complementary. There is some positive, there is some negative attached to it, there is some ups and lows attached to it. So there is some reception, there is loss of reception attached to it. So if we are receiving some data, we can mark it as 1. If there is a loss of reception, we can mark it as 0. So in later sections, we would see how computer judges that there is loss of reception happening, there is loss of data happening. Maybe in the next lecture tomorrow, we would be discussing that. That comes under transfer control protocol, a specific protocol. We would be discussing that tomorrow. So let's move ahead. So major point over here is that internet records every information in zeros and ones, even the electric signals, even the light signals, even the radio wave signals. And we are constantly trying to find better and better ways to transmit information in forms of ones and zeros. But the founding principle remains the same. What is the founding principle? That every device connected follows the same protocols, so that when they receive data in form of ones and zeros, they all interpret in the same way. So the founding principle of how internet works is every device follows same protocol, so that on receiving data in form of binary combinations, they all interpret in same way. So that's why so that's the reason why we can get a smiley face from a computer all the way in North America. So for instance, there's a computer, there's a guy sitting in America and there's a guy sitting in Asia. So if they want to connect to each other, the reason they are able to connect is they're following same protocol, and their computer, because of this, is able to interpret the data in same way. So if this guy tries to send a smiley to his friend in Asia, for instance, we connect it over here, and the guy is trying to send a smiley face. So same smiley face would be read in Asia as well. The connection is established, and now the same smiley face the other guy can receive. So what we are trying to explain over here is the data that was being sent from here is interpreted in same way over here. And this is happening because of same protocol. The devices are on same protocol. They are following same set of rules. They are not under different rules. So they are following same set of rules. So that's how the communication is happening without any change of data along the way. So this is the internet wires going through one computer to the other. Now, our we can so far we've understood that around the globe there are many computers, many devices, like billions of devices connected. So how can a single wire communicate with so many devices? How can one wire carry all the information flowing through the internet? Daily we see that gigabytes of information flowing through the internet every second. Every user is sending or receiving some information, accessing some data. So how is it possible that one wire can do all of this? So in reality, it's not one wire. It's not a one wire. It's a lot of different wires put together. So this is the case. It is not one wire.
To
There are
make a
many
joke,
different wires that are put
Rahul,
together.
to
Yes,
make
Talash.
to make a joke, one day one of my colleagues, we were teaching Java, and when he was seeing all these strings, the data types and the arrays and complex structuring, he said it is magic. Whatever is happening, it's magic.
And actually, that is true because sometimes we do not understand what's happening under the hood. There is so much more. Okay. So coming back to the session, so where were we that it's not a single wire. Internet is not one wire. It is lot of different wires put together. So some of these wires may be radio waves. For instance, this could be a radio wave. This could be a electric wave. This could be a fiber optics. So all different wires connected together. So it's a vast network of wires connected in different ways. So different wires connected together forming a vast network. So now we all know what a network is, right? So just a recap, network has three conditions: group of devices connected together, sharing information, and over same protocol. So if any group of devices are following these three conditions, connected together, sharing information over same protocol, they are forming a network. So now moving ahead, let's understand in detail what a network can be. We know what it is. What are various types of network? So let's understand in more detail over here. So let's move ahead with a very basic example, a very simple network. So here are two computers connected together to form a simple network, right? So computers in this network are able to send information from point A to B. So suppose they're on same protocol, they are connected and they are able to share information from A to B. So they are forming one simple network. Let's make it a little bit more complicated. We have, suppose we have four computers with us, simple four computers with us, and we can simply connect every single computer to every other computer, right? And this is great. Here, every single computer is connected to the other, but there is a very big problem associated with it. This kind of setup is not scalable. So it is not scalable. What is scalability? Scalability is when you can make a system grow as the technology grows, as the advancement happens. But if number of computers increase, we cannot connect each computer to each of the other computer, because there are billions of devices on the internet, and it is not possible to have a direct connection between billions of devices. We cannot connect one computer with billions of computers out there. So there must be some way. Well, we introduce an intermediary machine to overcome this scalability problem, the problem to expand. Suppose there are multiple computers and we cannot connect each computer to one computer and this each computer again to some other computers through single wires. To overcome this problem, we introduce an intermediary machine. It's very important, an intermediary machine. So just like this is our intermediary machine. So in small networks like this, suppose with four computers, this machine is called a switch. So remember this term. In a small network like your home network, this particular intermediary machine, the intermediate between all the computers, is called a switch. Now, switch is responsible for routing information from one place to the other. So how this happens? Now, let's suppose if a computer at bottom left, this computer wants to So suppose this computer wants to get in touch with this computer. How this would happen? First, it would send the data to the switch. So this connection would be established, and then the switch would further forward it to the destination computer. So the connection, instead of direct connection, which was earlier there, instead of this connection, now connection is going first here, reaching the switch, and then going from switch to here. So now switch is good for small networks, say one room. So let's say we have a room full of 10 or 15 computers, a building of 50 computers. So it is good for those small networks. But once when we get bigger than that, then connecting every computer to single switch can be little bit too many connections. There would be so many connections. If there are more and more computers, we cannot connect them to a single switch. So what do we do? Here, we connect these individual networks together. So how do we connect these individual networks? So let's say you have 4 different networks or 3 different networks. So let's mark it. This is your home network. This is your office network. And this is some coffee shop network. So what is happening over here? How do all these computers connect together? For example, how any 2 computers in different network interact with each other. So if I want to interact this computer with this computer, how do I interact? They are from different networks. To send information between networks, we introduce another middle machine. There's another middle machine which is called router. You must have heard it. So this is the middle machine that is called router. Router connects each individual simple network through switch. So I'm repeating this. Router connects each individual network through switches. So this is how router is connecting. This gets connected to this switch. The router gets connected to this switch, and so on. So the way 2 computers in red box can share information now is that first information from our computer, the information from our computer A goes to the switch, then switch transfers that information to the router. Router gets in touch with the switch of the destination computer, and switch then in turn gives the information to the final device. So this is how the network happens when there are multiple individual networks. That is the role of router. What is the role? Connecting small individual networks through switch. So this is great. Suppose we have tons of network and that need to be connected. So let's suppose there are multiple more networks, and these networks need to be connected now. Now, if we connect all these networks to this particular router, it would be too much. There would be overload, or there would be overload of our router capacity. Then network connectivity of each device would be slow. So this would be like giving more work than router's capacity. How to overcome this? Now comes the global level. Suppose there are millions of computers and devices out there and trying to connect. How can we achieve that? Now let's level up all the way to the internet, all the way to the global level. So now let's understand internet at global level. So internet is really a vast network of routers. Now this is vast network of routers. These are all routers. These are not switches, these are routers. And this particular device is our switch. So vast network of routers. There are a few conditions we need to keep in mind. Each router is not connected to every other single router. For instance, this router is not connected to this one, and this router is not connected to this one. This router is not connected directly to this one. And so each router is not connected to every single router. There are only few connections. They are only connected to few of them. And why this is done? The reason is, let's take this example. Now, this router need not worry about many connections. It only needs to worry about the connection between this router and this router, this one. Only this connection they both have to worry about. Why? Because if this connection is broken, then this router would be in problem. So they make sure that this connection always stays in touch. So what happens now? Each router only needs to worry about few different connections, and this network of routers is what spans the entire globe. So entire globe, there are multiple. This is a very small depiction. Like there are many routers, uh, and they are connected through some of the routers, and that's how the internet happens around the globe. Let's move ahead and get some connection build up for our smaller networks. So what happens if a smaller network wants to connect to internet? All we have to do is choose one router to connect. For instance, this smaller network has chosen this router to connect the entire structure. This particular setup has chosen this router, right? Now, these routers that have been chosen, those are your internet service providers. Those are your ISP. What is internet service provider? The company to whom you're paying your internet bills. You've subscribed to a service from certain company. You have established their broadband services at your home. That is your internet service provider. These routers which establish a connection with your home network, office network, they are the routers maintained by your internet service providers, by the companies who are charging you for the service. They can charge you monthly, annually, or any other format as per their terms and conditions. So now you've chosen one router, you are online and you're accessing internet and connected to entire world. And that's how a small network, this is one small network, and this network is in one part of the world. And this network is in some other part of the world. Let's say this is in America and this is in Asia. This is how small networks in different countries can be part of same internet structure. How? They choose one router and those routers are somewhere or the other connected in the structure. Now, this bunch of routers is what people put a cloud on, and they sometimes call it as cloud, they sometimes call it as internet. So this is not a cloud. Cloud is way much more than this. So it is just a vast network of routers, and that's what an internet is. So if we have to define, it's a vast network of routers that is connecting small individual computer networks. So a vast network of routers connecting small individual computer networks. And now using this, if any two computers, for instance, our computer A and our computer B wants to connect, and if they are following same protocol, then they can communicate with each other. So for instance, this computer wants to get in touch with computer B. So this would first go to switch would go to this router would find the best possible way. This would get in touch with this router, then this, and this is the ISP for computer B, and then our connection to the switch and back to B. This is how a connection between A and B would be established across the globe. This setup I've shown is a very small setup right now for our understanding. So just assume like millions of routers are there set up across the globes at every landing station where the cables, undersea cables are coming to provide the service. Now we know what an internet is. It's just vast network of routers. So how do we tell internet where to send data? We know how connection is established, but how to tell that send data to B? How to identify what is point A, what is point B for the information to travel? This brings us to a very interesting topic, that is internet addresses. So every single device on the internet, every single device gets unique internet address. So the numbers you see, these are unique for every single device. No two devices can have same number. No, not even computers, not even routers, not even your switches. Every switch, every computer, every router, they have a designated list of numbers or unique internet address. So information is sent out to and from the unique address. To unique address or from unique address, the information is received. These addresses are called Internet Protocol addresses or your IP addresses. You must have heard IP address. So these addresses are your Internet Protocol addresses or what we call as IP addresses. So it's just like a mailing system. Assume mailing system. Let me give you a very nice example. Suppose you are sitting in New York and you want to write to one of your friends in Michigan. And then that place in Michigan must have a unique address where you want to post that letter. So you get in touch with the mailing systems, the mailing services, postal services, and you tell them that address. And then the postal services goes to that address and deliver your letter. Same way your computer needs to have unique address. Suppose this computer is in New York and this computer is in Michigan. Now, this New York computer will get in touch with the postal service. What is the postal service? The postal service over here is internet. And this New York computer will deliver my information to this address, this particular address. Now, the information would be taken by the internet through various routers and delivered over here. So this is how information is traveling. And uh, we have heard about servers as well. Let's see how they are attached in this system. So these are some machines on the internet connected to listen to some particular request. So servers are where the websites are hosted. Servers will sit at a particular IP addresses. Servers will have their own IP address and they listen for requests coming into the servers. So let's say if they hear saying, hey, can you send me homepage? Or hey, can you send me the login page? Can you show me this video? Can you show me this image? Then the server responds to the request and sends the data needed along with proper HTML, CSS code that makes up the requested website. So what happens is, suppose this computer requests for a web page. The request goes via certain routes and gets to the server. Now server checks the request and sees if that server has the particular data associated with it. Now, if that particular website was hosted on that server, then data is available. And if data is available, then server respond with all the required information and the HTML, CSS back to the designated device, and the device is able to see the requested website. So now server sends the data back through the same route, and the device is able to view the page. So device is able to view the page. That's how things are happening. So a question might come to our mind that I never type this number ever, 207.132.223. I do not type this number ever to identify to a server, to get in touch with the server. So what's happening over here? So we usually, if we take a normal example, we usually type we usually type the name of website. For instance, we go to a browser and type facebook.com, google.com, or amazon.com, or any other random website. So what's happened here? So here the domain names or domain name systems come into play. So what is domain names and what are domain name systems? Let's see that. The domain names and domain name systems are very important for us to understand. Let's take a very nice example to see. So for instance, we have a particular website address. Let's say I'll write amazon.com, amazon.com. And here, let me write it. The full address, I'll write it like, and then comes your World Wide Web, and then amazon.com. Now, what's happening over here? If this server requests for a particular website, say this website, there are certain uh, parts of this URL that the server understands before providing the home page. And for them to understand this particular website, domain names come into play. Domain name systems come into play. So this is what we know is a protocol. This entire thing is called URL, your Uniform Resource Locator. This thing is your protocol. This thing is World Wide Web. This tells that we are targeting the World Wide Web. We are entering the World Wide Web. This Amazon is your domain. And this .com is called TLD, top level domain. So all these paths are very important. So what happens over here, the DNS, the domain name system, converts this name into the associated IP address associated with this web page. Suppose there is an address 111.23.16.100. So if this is the website address, this is the address on the internet, the IP address, the unique address, the domain name systems will convert the domain name into the IP address, And then this IP address is identified by the server. If the server holds that website, if that website is hosted on that particular server, then that IP address is recognized, and then the server provides the required data to the user so the user can see the Amazon homepage. So how user tells that I want to see homepage, I want to see login page. So after the domain name, after the top level domain name comes the path. So if I write over here the amazon.com and here homepage, this is your path. And this is your domain, and this is your top level domain. So we will understand top level domain in just a bit. Let me show you a site wherein you can check the domain names of a particular website. So let me pull up the browser and show you a real life example that if I put this IP address, this is a dummy IP address. This is not the IP address of Amazon. If I put, we are just assuming that this address to be the amazon.com's IP address. So if I put a particular IP address into my browser, the browser will open the web page. The browser need not specifically have the English word. It only needs to know the IP address. So let me show you a website where you can check the domain and convert into and figure out the IP address. So let's pull up that website. Yeah. So this is the DNS checker website. So for instance, if I write Wikipedia over here, so if I write Wikipedia over here, this particular website has stored certain domain names and has known the IP addresses. So all the IP addresses you cannot find on internet. Certain companies have provided the IP addresses so that user can access it, but all the companies do not provide. So this is the IP address that we have received. So what I'm trying to tell is this is the actual address. The internet only needs to receive this address. Internet does not need to have the English language URL. So if I open Google and if I only put in the IP address, if I just remove it from my memory, if I put it only the IP address and click enter, the browser will take me to the Wikipedia's different websites provided. So just see, I've never entered this particular URL. The this particular IP address took me there. So this is the real address that is stored on the internet. So if I click over here, I would be directed to Wikipedia. This is Wiktionary. This is Wikicodes, Wikibooks, several functionalities. So another example, these are hyperlinks. So if I click and show you, this is a hyperlink. I was directed to this. Again, these are hyperlinks. I'm being directed to some other web page on the same website. So a beautiful example to see. So the main point over here is that DNS converts your domain name into the IP address. Why? Because it is the IP address that internet understands, that devices understands. So let's get back to our slides. I'll clear this up and we'll cover top level domain. So let's briefly recap what we did so far. So domain names are like nice human readable names of a website that we use, like Amazon.com, Wikipedia.com, Google.com, and many more. So before hosting the website on server, the owner of website, the one who has created it or bought it, can choose the domain, and he can choose the only domain name that is available. If a particular domain name is taken, that domain is not available to other users. So for instance, if this is Amazon.com, so this Amazon has already been taken by someone. Now the other person cannot take Amazon.com. They can take amazon.org if that is available, amazon.in or .dev. So you must have seen these days that there are some websites with org and dev or .ca and many other this top level domain names. So why different top level domain names were there? So let's understand that. So a domain name system is not just one server. It is not single server which is trying to convert all your domains to IP addresses. That would be very much a difficult task for this particular server. What happens over here is there are a bunch of servers, which each server has different functionality. This is our first server. This server only catches the domain name. And this goes to this particular second server, that is root server. The root server will tell, okay, what's the top level domain? Is it .com? Is it .org? Is it .in? This root server directs to the particular top level domain name servers. Like this domain name server is dedicated to all the websites that end with .org. This is for .com. This is for .in, and so on. So if this root server finds that the website has .com, it will direct this particular server's request to the .com server. If it detects that my website address is .in, it would direct to this particular server. And once the query reaches a particular top level domain name server, then it goes to the servers wherein the .in servers have. Uh, so let me show you over here. So for instance, the website address is Amazon.in. Now our query first goes to the root server. Now root server directs it to the .in server. So I'll just clear this one up. Now further, .in servers have multiple servers with the domain name information that ends with .in. So the server checks where this particular domain name is lying. Now, if it is lying over here at this server, and that server provides the IP address. Now, all the way from this, back to root server and back to this server, the IP address is reaches. So that's how the DNS servers are working. Bunch of servers. First, the request goes to root server. Root server will take it to the top level domain name server. That will check, okay, which particular domain, top level domain is used. Is it .in? They are separate for servers for different top level domains, separate servers for .com, separate servers for .org, separate servers for .in. And in those servers, the domain name is being searched. And if the domain name is found, it is converted to the respective IP address. So that's how the domain name systems are working together. That's how domain names are working. So what domain name does, it associates easy readable name with actual addresses of the website on the internet. So what domain name systems are doing for us, they associate the readable names with the IP addresses. They translate human readable names. For example, Amazon.com to machine readable names, that is IP addresses. So we understood how this works, right? So any questions so far? Anything you want me to explain, anything you want me to show you again, any slide you want me to review?
Yes, like a small question. So, each server has its own IP. So, is it possible to one computer? If someone is loading in one computer two websites, so what will happen at that time?
So if I understood correctly, like if someone is loading two websites at same time, right?
Yeah, the same computer. So the computer has only one IP. So the
So
website,
what's happening over here is, suppose you're trying to add items to your Amazon cart. At the same time, you're checking your Gmail account. So that's what the query is, right?
no, no.
How is
For
this
example,
possible,
no, no.
right?
For example, so the Amazon and Gmail are in, so they were uploaded in the same computer. So then how we can find that?
So if Gmail account is opened on two different computers, is that
No, no, one computer, one computer. So I could not explain well. So, for example, I have a computer. I have two websites. Okay.
okay?
So my computer has only one IP.
Right.
So how can I load two websites in the computer in my computer?
So just understand this. I'll show you. So this is your computer. Assume this is your computer and this is your IP address. And you're trying to load two websites, right? So the website address is not associated with your IP address. This identifies your computer. Now the website address is a different IP. Website has different IP. So for instance, this is Amazon IP, a random IP. Similarly, Google will have a different IP. Now different requests goes. One will go to the Amazon server and one would go to the Google server. And suppose this is your Amazon query happening. And at the same time, the Google query would go like somewhat like this way, some other ways. Suppose this is the pathway for Google. So once this gets fulfilled, it would come back through the same route and it would come back to the same route. For this particular server, the device IP is important. For this particular server also, device IP is important. And how they recognize if they hold the data of Amazon, if they hold the data of Google, by the website address. The website address is important for the server. The website address is not important for the client. It is not important for you. For you, what is important is getting in touch with the right server of the company. So Amazon has 111, suppose, IP address. Google has 222 address. So these addresses are important for their servers. So if this is Google server, Google will check if that particular IP address is stored in this server or not. If that is stored, it would provide the HTML and all other documents for the client to see. And where it would send back to that particular IP address of device. So the device address is just to make a connection with the data source. The website address is required for data source to identify if they hold that particular data or not. The domain name services are important for the servers. It is not important for the client. Client, we enter English names, right? English readable names. Now that is what we know. That is how we communicate. But servers can't communicate. Server internally converts this particular name to the IP address. So that's how you're able to load multiple websites on same device. Because server will check if that IP address is there, it would provide the data to the IP address of your device. So I hope I'm able to make things clear with this, or should I give you some other example?
Yes. So again, so just so for first one is how does the internet knows that this the web or the address is located to this computer. How does it know? It is through the IP.
So the internet knows that address is through IP. Let me draw something. Let me draw this for you. So let's remove everything and let's draw this. So what's happening is, suppose we are considering this device, a device whose IP is 2.1.5.2. I'm considering this device. Now I want to access two websites. These are two servers out there. I do not know where these servers are located. I just want to access Amazon and access Google at same time. So there are a bunch of routers in the network. So they are connected in some way or the other to each other. And this is how my connection with the server of Amazon is happening. This is how my connection with Google is happening. So when I try to access Amazon.com, First, this is converted to the IP address by DNS. This IP address is not important for me. It is important for this server, because server do not understand English language. Everything is converted to binary. Even these IP addresses are converted to binary. So this IP address, so my request goes over here, checks which route this IP address is, because route, suppose this is your home and this is your friend's home. Now you know the address, and there are multiple ways, like a highway out there. You know, you can go from here also. You know, you can go from here also. How is this possible? Because you know the address. That's how the internet knows, okay, this server is being accessed, this address is being accessed. So it knows, okay, there was a pathway being created between these connections. I can reach it from here. Once it reaches over here, it provides the IP address of the request of the web page you asked. Once that IP address is identified by Amazon, it checks, okay, I have the data. It provides back the data to you. Similarly, when you're trying to access Google, you are just writing google.com, and that is converted to through DNS into the IP address of Google. Now, this IP address has nothing to do as of now. First, the request would start going from here to here to here towards the Google server. So the internet knows that where the server is located and connection has been built, because this is happening all through wires. So for instance, when you switch on a bulb in your room, the wires know automatically that there is a connection between switch and the bulb, and the current flows through that. The wires we have set up, the current knows that connection has been built. If the connection is right, the current would flow. Similarly, if these pipes and these wires have been set up, the internet would flow. Now, on reaching the Google server, now the internet would provide the IP address and ask the server, do you have anything associated with this IP address? If Google says yes, then that would provide bunch of information to the user as a response. So this is how things are happening. IP address has nothing to do till it reaches the server. So the internet only identifies, so we would be covering this, that how internet knows under the request response headers and body and headers in our next lecture, when we would cover the protocols, different protocols like transfer control protocol, your request response protocol. So there we would be studying that how the computer knows where to send the data. So as of now, just understand that these IP addresses make sure that the information is sent to the unique address and received from the unique address. So, did it make more, look, are you able to understand it a little bit more idea?
Yeah, let's understand. So that's a little bit, so that maybe I could not ask my question well. So actually, the guy by the
So
name
you
of
can
Shakib,
type, it in the chat.
yeah, he typed it. He the question, so the Shakib, he asked, my question was that,
Okay, let me check.
his,
Just allow me a moment. Let's check that. Okay. So the question is, how to host or how to host two websites on single computer. So you are not hosting website on your computer. You are hosting website on servers. So servers are where the websites are hosted. So just notice this. So servers are where the websites are hosted. You are not hosting website on your computer. Here is where this website is hosted. So this web server is owned by Amazon. This web server is owned by Google. So if you have two websites associated with them, your website is getting hosted in these servers. There are multiple bunch of servers, like we saw in last class, that Google has so many servers. These servers are provided to every user to enjoy the service, where they can host, they can store their data, they can retrieve the data. So you're not hosting your website on your computer. You're hosting on the company's server, and you're just accessing them by providing the right request. And if that server holds the information, it would provide back you with the response. So millions of websites you can host. This device, this is front-end device, remember. This is just to see, just to display the information. It is hosting nothing on itself. The information or data is hosted in the backend part. So if you were there in the last lecture, we understood how servers work. So there are three parts. First part is your web server. Second part is your backend language. And third part is your database. This is your database. And this is the entire construction of a server. These servers that we see, they have three parts: web server, backend language, and your database. Now, database stores all the information. Backend language communicates with the web server and the database. And the web server receives the request and provides back the response. So you're not hosting anything on the computer. You're hosting on the server, on the company's server.
Okay, okay, good. Thank you.
You're welcome. So Omid is asking that how is information not being mixed? So if we are sending some information or speaking from a computer from Asia to America, we know each has IP address. How come it never gets mixed or never goes to wrong person? So because every device has a unique address. So if these addresses are unique, it can never go to a wrong person. When you're trying to get in touch with your friend or when you message them into their account, that account is associated with this particular client. So that's why the internet follows a particular path to reach to this particular client. So these
Hey Rahul, can
addresses
I ask
are
a question?
unique.
Sorry to interrupt, Rahul.
Yes, please.
So the question comes to me that if we go back to IP address, subnet mask, gateway to get a little bit more of IP addresses, then we can learn this all. I believe everybody's confused because IP address has its own lecture, how it creates, how it studies, how it works with the subnet and gateways, stuff like that.
Your voice is a little bit breaking. Just can you just type a little bit in the chat or tell me a little bit more because it's breaking, or someone else who's able to hear can explain me the question, please.
Sure, let me, I will type it for you.
Yeah, speak a little bit louder.
Can I ask my question?
Yeah, sure, please.
So we talk about the binary digits. So we know like binary digits make for like every alphabet have like a specific number. So every alphabet like convert by the number. So how do we know like how the picture and the videos, how they convert to the binary digits?
So what happens is every picture, when we go to design principles, every picture is divided into pixels. So very brief overview I'm telling, because this is very deep of how an image gets converted. So every picture is divided into pixels. It is broken into simple information, small packets, and each pixel is then transmitted individually. And once this reaches the client, this information gets collected together and the picture is formed. How this is happening? Each pixel has some metadata information regarding to whom this pixel is being sent, from where this pixel is being sent, and a particular number associated with it. Like this pixel is numbered 1, this is 2, this is number 3, and so on. And this is converted into the electrical signals. And the electrical signals we saw, like how they are converted to ones and zeros. So it might be electrical signals, might be radio waves, might be anything. So once they reach the receiver's end, according to the numbers, these are again packed together to form the correct image. So everything on the internet travels in forms of packets. So regarding packets, we would be studying more about in detail that what are packets, how they are transferred. So this is a very brief thing that how images are being transferred. They're broken down into pixels. Every pixel is being transferred and so much more. There is so much more happening behind the scenes.
Okay, I
So
got it. Thank you.
So just remember that every packet of information, that every chunk is numbered. So we would see this in detail tomorrow also, that what are packets. But as of now, every packet is numbered so that when it reaches over here, it is being assembled into correct format. And this happens through one of the protocols that we would be studying tomorrow, that is TCP, your transfer control protocol. And the connection established is called your TCP IP connection. So we would be studying this in detail, that how actually data transfers. So that is the last part of the puzzle, that how internet is working. So we would be discussing that tomorrow for sure. So Ahmed is asking, congestion never happens among all these servers. So Ahmed, there is no one server. There are millions of servers across the globe, and there are millions of servers distributed among various companies. Like Facebook has so many servers, the Amazon has so many servers, Google and many other companies, and these servers are collectively providing you the service. You can choose any of the server from any of the company. You can use one service of Amazon, you can use one service of Google, you can use some service of Facebook. So that's why these servers never get congested. So there are millions of servers provided to every user, so that it's ample storage and ample high speeds are always there. It's just that number of servers are very much more. So Mustafa is asking that, have a class on IP address and what subnet mask is and what a gateway is. So these are pretty advanced topics, and they are associated with networking, like very much into depth of networking. If you want to study networking concepts, then we can have that. So let's ask if everyone is comfortable with the networking concepts, because at the end we would be moving to writing the front end and back end part. All I wanted to make you understand from all these concepts is to have an overview that how internet is traveling, how your web page would travel from your end to the client's end to the receiver's end, how backend is happening, what is the structure of server. So the other topics, it depends if everyone is ready, if everyone wants to go into the depth of IP addresses, subnet mask, and gateway and other deep concepts. So I would definitely take that.
I think we would not need it as it's most, as you said, it's mostly into the networking. If anyone is
Exactly.
interested, we have a cybersecurity class running right now. You can jump into our cybersecurity class sometime. You will, if you are interested, you will most likely learn a lot with regard to the network and network security issues and anything related to the in-depth on the IP addresses and subnet addresses. So here, the the goal behind our lectures here on the prep course is that we at least understand the background on things that we will be discussing in the future. So if you know at least these backgrounds, I think that's more than enough.
That's correct, Talash, because right now the topics that we've covered so far, they are also way much more than other developers know. I can assure you, you ask any front-end developer or any back-end developer, even those developers are not having clarity regarding these topics, because they never try to go behind the scenes, what is happening. And you should all thanks to Talash that he organized such a beautiful prep course with me, that let's give them a deep understanding how things are working before actually diving into a code, before actually getting our hands dirty, before actually creating websites. Let's work on the basics, the core concepts that a computer science graduate knows after 4 years of rigorous study. So these are pretty much already a depth level for the front end and back end developers. So I think sticking to this part of curriculum is way much more than diving deep into other deep topics. So any other
Yeah,
questions?
true, true.
Are we starting the coding like at the HTML or CSS?
So the coding is the part of core programming language, and that is that is the core course, and we would be starting it next month. The first month we are providing with the basic concepts. The next topics after we cover these internet, the next topics would be your application development cycle, your application design process. What makes your web page is a great web page? What makes your web application run faster? How can you make web applications as per the client needs? What are media queries? So that would be the next section. After that, we would be studying tools and technologies used by front-end and back-end developers, which code editors you would be using, which Chrome browser, which developer tools you would be using, which browser you would be using, and so much more. Other tools. I'll quickly start with the video. Do let me know in the chat if you can hear the sound, okay? Allow me just a moment. I'm pulling the right screen for us. So just give me a yes or no. Yes, perfect. I'll start it. It's a very interesting video about the topics that we covered today. Enjoy.
Hi, my name is Paula, and I am a software engineer at Microsoft. Let's talk about how the internet works. My job relies on networks being able to talk with one another. But back in the 1970s, there was no standard method for this. It took the work of Vint Cerf and Bob Kahn to invent the Internet Working Protocol to make communication possible. This invention laid the groundwork for what we now call the Internet.
The Internet is a network of networks. It links billions of devices together all around the globe. So maybe you're connected with a laptop or a phone through Wi-Fi, but then that Wi-Fi connection connects to an Internet Service Provider, or ISP, and that ISP connects you to billions and billions of devices around the world through hundreds of thousands of networks that are all interconnected. One thing that most people do not appreciate is that the Internet is really a design philosophy and an architecture expressed in a set of protocols. A protocol is a well-known set of rules and standards that, if all parties agree to use it, will allow them to communicate without trouble. How the Internet actually physically works is less important than the fact that this design philosophy has allowed the Internet to adapt and absorb new communication technologies. This is because in order for a new technology to use the Internet in some fashion, it just needs to know which protocols to work with. All the different devices on the Internet have unique addresses. An address on the Internet is just a number, similar to a phone number or a sort of street address that's unique to each computer or device at the edge of the network. This is similar to how most homes and businesses have a mailing address. You don't need to know a person to send them a letter in the mail, but you do need to know their address and how to write the address properly so the letter can be carried by the mail system to its destination. The addressing system for computers on the Internet is similar, and it forms part of one of the most important protocols used in Internet communication, simply called the Internet Protocol, or IP. A computer's address then is called its IP address. Visiting a website is really just your computer asking another computer for information. Your computer sends a message to the other computer's IP address, and it also sends along its origin address so the other computer knows where to send its response.
You may have seen an IP address. It's just a bunch of numbers. These numbers are organized in a hierarchy. Just like a home address has a country, a city, a street, and a house number, an IP address has many parts. Just like all digital data, each of these numbers is represented in bits. Traditional IP addresses are 32 bits long, with 8 bits for each part of the address. The earlier numbers usually identify the country and regional network of the device. Then come the subnetworks, and then finally the address of the specific device. This version of IP addressing is called IPv4. It was designed in 1973 and widely adopted in the early 80s, and provides for more than 4 billion unique addresses for devices connecting to the internet. But the internet has turned out to be much more popular than even Vince Cerf imagined, and 4 billion unique addresses won't be enough. We're now in the middle of a multi-year transition to a longer IP address format called IPv6, which uses 128 bits per address and provides over 340 undecillion unique addresses. That's more than enough for every grain of sand on Earth to have its own IP address.
Most users never see or care about internet addresses. A system called the Domain Name System, or DNS, associates names like www.example.com with the corresponding addresses. Your computer uses the DNS to look up domain names and get the associated IP address, which is used to connect your computer to the destination on the internet.
And it goes a little something like this.
Hey, hi there. I want to go to www.code.org.
Yeah, I don't know the IP address for that domain. Let me ask around. Hey, you know how to get to code.org?
Yeah, I got it right here. It's 174.129.14.120.
Oh, okay, great, thanks. Yeah, I'm gonna write that down and save it for later in case I need it. Hey, here's that address you wanted.
Awesome, thank you.
So how do we design a system for billions of devices to find any one of billions of different websites? There is no way one DNS server can handle all the requests from all devices. The answer is that DNS servers are connected in a distributed hierarchy and are divided into zones, splitting up responsibility for the major domains, such as .org, .com, .net, etc. DNS was originally created to be an open and public communication protocol for government and educational institutions. Because of its openness, DNS is susceptible to cyber attacks. An example attack is DNS spoofing. That's when a hacker taps into a DNS server and changes it to match a domain name with the wrong IP address. This lets the attacker send people to an imposter website. If this happens to you, you are vulnerable for more problems because you are using that fake website as if it is real. The internet is huge and getting bigger every day, but the domain name system and internet protocol are designed to scale, no matter how much the internet grows.
Perfect. Okay. Right, no? Wonderful, right? So these videos give us so much more idea that how things are happening. It was such a wonderful video telling how domains are divided into top level domains, and that particular set of servers now looking for a particular domain name. So any questions, anything you want to ask, very quick, just a 2 minutes for any questions which have been left from today's topic, and or else we can wrap up.
Rahul, I have a quick question regarding the using the DNS or IP address. What is the most secure way to not, find out by the hackers or hunted by hackers in world? Yeah.
So regarding security, you've heard there is HTTP and there is HTTPS. Mostly, if you see the website address, if this website is coming, this is under HTTPS. So what HTTPS does is the extra S is the security level. So that encrypts the data. So let me, I created one slide regarding that. Allow me just a moment. I'll pull that up for you. It's an interesting question. Let me pull that up for you. Okay. So are you able to view my screen, right? Is it?
Yes.
And you can see the HTTP written over there, right?
Yeah.
Same screen. We're on same. So let's understand your question, how you can protect your data. So if websites are following HTTP protocol, they are not secure. So if websites are following HTTPS protocol, then that is secure. That is one way to check if a particular website is safe or not. If you visit a website, just check the very initial part of the domain. I'll show you a visual regarding that. So this is an HTTP connection being built. So assume this is the browser. This is the browser holding a website with the HTTP. Now, if you enter your details, supposedly card number. Now, this card number, if someone has ability to intercept this connection, they would be able to see the card number in the exact way. In the same way, the 4242 and so on, the hacker would be able to see. But if a website is using HTTPS, then that particular data or that particular connection is encrypted, and that is encrypted through another technology, that is TLS, transfer layer security. So that is transfer layer security. What it does is it encrypts the connection. It makes the connection more secure. Now, if a particular hacker comes in the scene and tries to intercept this particular connection for us, if that particular hacker is trying to intercept, then the hacker would see only the jumbled data. So the answer to your question is, if you want to check if a particular website is secure or not, just check the first part of domain. Is it HTTPS? Then 99% chances are secure, because this security part through transfer layer security is very hard to get into. The parameters or the checks that have been put by companies are intense, and it's not easy to get into by the hackers. So most likely 99%, 99.9%, these websites are secure. And if a hacker gets into it, they would see the jumbled data. They would not be able to see. But if the website is a simple HTTP, the hacker would be able to see the data. So that's one way to check if a website is secure or not.
Thank you so much, Rahul.
You're welcome. Talash, I'm just going to pull up the link and I'll share that with you.
Okay.
So thank you so much, everyone, for joining today. We'll meet tomorrow, same time, and we'll discuss some more important topics.
Yeah, good day. See you all.
Have a great day. Thank you.